We are now ready to start looking at problems that involve our actual trig functions. So we went over this in class, and you can watch my YouTube videos, so I'm not going to give a lot of explanation. I just want to solve these problems. So in this review, there are three right triangles. We're asked to find the six trig functions, so I'm just going to choose one of them. I'll do this one. So this side's length is square root of 3, this side is 2. And in this case, we're interested in this angle up here. And we're asked to find all six trig functions. So for right triangles, this is sort of like right triangle trigonometry. Very, very briefly, the key things are the three angles of a triangle equal 180. So that's what we use sometimes, 180 degrees. We also use the Pythagorean formula, which for a right triangle says if you square the hypotenuse, that equals the sum of the squares of the legs of the triangle. And we'll actually use that in a minute. And then finally we have the trig functions. So, TOA, where the H stands for hypotenuse, O stands for the side opposite the angle you're looking at, and the A stands for the adjacent side. So that's all the stuff you need to start working these. Now, the way I approach this, the way I taught it in a class is sine and cosine are really the key trig functions that I use a lot, and then tangents next, and then the last three are sort of the minor ones. And once you figure out the sine, the cosine, and the tangent, the other three are easy to get. So that's the process we're going to follow. So here we go. First thing you have to do is, in order to apply the trig functions, you have to know the lengths of all three sides of your triangle. This is the hypotenuse. A lot of times they call the hypotenuse, I would just call it H for hypotenuse. Pythagorean formula says if you square the length of hypotenuse, it has to equal, you take this leg, or this side, and you square it, and you add it to the other side squared. When you square a square root, it ends up being 3. 2 squared is 4. So h squared is 7. If I want to solve for h, take the square root of both sides. So the hypotenuse is square root of 7. Now that I know the three sides of the right triangle, I can now go ahead and start applying my trig function definitions to solve this. So very briefly, the sine of theta, so opposite over hypotenuse, opposite is 2, hypotenuse is square root of 7. Now I know in previous math classes, a lot of times in algebra you were taught you never leave a square root in the denominator of a fraction. Although now when we get to trig, we don't worry about that too much. This is a perfectly fine answer. There's no need to rationalize the denominator. Cosine, so ca, adjacent over hypotenuse, so adjacent is square root of 3 over square root of 7. Someone might want to rewrite that as this. These are both the same either way. I would probably just leave it like this. And then finally, the third one we want to find is the tangent. Tangent's TOA, which stands for opposite over adjacent. So we have the sine, cosine, and tangent. Now, for the other three trig functions, remember, trig functions are sort of grouped in pairs of two. The sine gets paired up with the cosecant. So it turns out the sine and the cosecant are reciprocals of each other. So what's nice is once you find the sine, what that means is the cosecant, you just take the sine, and if it's a fraction, you just flip it. So if the sine of theta is 2 over square root of 7, the cosecant of theta is square root of 7 over 2. The same way the cosine sort of paired up with the secant. So if I want the secant of theta, I simply take the cosine and I flip that. So the secant of theta ends up being square root of 7 over square root of 3. And then the last one is the cotangent of theta, which is the reciprocal of the tangent of theta. So I flip the tangent of theta to get the cotangent, and it's square root of 3 over 2. All right, so there are your 6 trig functions. So once again, given a right triangle, you know the lengths of the 3 sides of the right triangle. It's not too difficult to come up with the trig functions. So based upon that, let's do some other kinds of trig problems that will involve right triangles. Here's the first one. Sometimes you're given a problem like this. You're given the trig function of an angle, and we're also told that the angle, I didn't write it, is an acute angle. Acute means, if we're thinking in terms of degrees, it's between 0 and 90 degrees. Matter of fact, now's the time maybe to just do a quick reminder of, when we're talking about angles on top of the XY coordinate system, we break this up into quadrants, right? This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. And a lot of times you like to think of the signs, the positive and negative of x and y in each quadrant. So if we think of like x, y, if x is first in quadrant 1, x and y are both positive. In quadrant 2, x ends up being negative and y is positive, right? Because it's the negative x-axis. In quadrant 3, both x and y are both negative. And in quadrant 4, x is positive and y is negative. Now, as it turns out, when we start working on these trig functions, what becomes important, once we know which quadrant our angle is in, then that helps us to determine whether our final answer should be a positive or negative number. You'll see me do these in a few minutes, but just for now, let me make this point, and then we'll talk about it later. Whatever quadrant I'm in, if I'm trying to decide whether my cosine should be plus or minus or my sine should be minus, here's how I do it. Cosine tracks x, the sine tracks y. What does that mean? If my angle is in quadrant 2, and then I'm trying to find the cosine of the angle, which is in quadrant 2, in quadrant 2, like x is always a negative number, and cosine tracks x, cosine's the same as x, in quadrant 2, the cosine is going to be a negative number. Say my angle is in quadrant 4, and I'm going to try and find the sine and the cosine. When I go find the sine, because the sine tracks, or it's just like y in quadrant 4, what is y in quadrant 4? Y is negative, which means the sine is negative. So if I have an angle in quadrant 4, the sine is going to be negative, and the cosine is going to be positive. All right, if that's not quite clear, once we do a few problems, you'll see it. And that's why this becomes important for this problem. Here, our angle's acute, which means we're in the first quadrant. You know what that means? When I go calculate my trig functions, my sine and cosine, since x and y are both positive in quadrant 1, that means my sine and cosine values are all going to be positive numbers in quadrant 1. So I know that from the top. Sometimes I even write, when I first start, I write down what quadrant my angle is in, because that becomes important when I finish these problems. So here you're given a trig function. We're told this about the angle. Our assignment is find the other 5 trig functions. In other words, there are 6 trig functions. We already know one of them. They gave us one of them, so we want to find the other 5. So how do we do this? Here's the way I like to do it, the way I showed you in class. I take this trig function, and I'm going to go create a right triangle based upon this trig function. And the idea is tangent of theta is 1/2. According to my definition, so-called TOA, tangent is opposite over adjacent. Just to make it very clear, opposite over adjacent, that means I could have a right triangle. I could create a right triangle where the opposite is 1 and the adjacent is 2. And that's what I'm going to do. I'll put my angle down here. I'm saying for this angle, the length of the opposite side is 1. The length of the adjacent side is 2. Right? So if I didn't give you this and I said, here's this right triangle, what is the tangent of theta? You would say tangent of theta, TOA, opposite over adjacent. Tangent of theta is 1/2, which is what we have. So it's almost like we're taking the trig function and going backwards and creating a right triangle based upon the trig function. Now to figure out the other 5 trig functions, sometimes I'm going to need the hypotenuse. So I need to go, once again, use Pythagoras and calculate the hypotenuse. So once again, h squared is 1 squared plus 2 squared, which is 5. Looks like h is going to be square root of 5. So now I really have what I need to figure out the rest of trig functions. So let's start with the sine. So-called TOA, so opposite over hypotenuse. Now when you do these kinds of problems, I want to emphasize now it's really a 2-step process. The first step is you use your trig function to get the value of the number. But the second step is you have to go then determine should that number be a positive or negative number, and that's going to be based upon what quadrant the angle is in. I'm in quadrant 1. The sine in quadrant 1 is positive, so therefore the answer is 1 over square root of 5. Cosine, so ca adjacent over hypotenuse 2 over square root of 5. Now in quadrant 1, is the cosine plus or minus? Well, as it turns out, in quadrant 1, the cosine is plus, so therefore the cosine of theta is 2 over square root of 5. Let me write tangent here, although they've already given it to me. I don't need to figure it out. Now I can go find the other three trig functions from just flipping these. And the nice thing is the plus and minus of these other three trig functions will be the same as the one they're paired with. So if sine theta is 1 over square root of 5, cosecant of theta is square root of 5 over 1. Normally I don't write the over 1. And since sine is positive, cosecant's positive. So basically cosecant theta is square root of 5. Cosine gets grouped with secant. So if I flip the cosine, get square root of 5 over 2. And since the cosine is positive, the secant's also positive. Tangent's 1/2. Cotangent I'm going to flip. So if you flip 1/2, you just get 2. Tangent's positive, cotangent's positive. There are the other trig functions. All right, hoping not too difficult. Now let's do another one just like that, except it's going to be a little more complicated, or just some things you have to pay attention to. So how about if let's do this one. Same idea. They're going to give you a trig function. So they say the cotangent of theta is -2. And then they also tell us the secant of theta is less than 0. What's it mean when something is less than 0? Means it's negative. So they're telling us the secant is going to be negative. So, and the same problem, find other 5 trig functions. So I'm given one trig function, this angle theta. I'm given some more information, and I'm asked to find the other 5 trig functions. So here, this one's a little more involved. First of all, I've got cotangent and secant. Let's think about cotangent. I really don't like to work with cotangent. So normally if I have a problem where I have a cotangent, I'm going to switch it to tangent. So if cotangent of theta is -2, or if I think of it as a fraction, I could say it's -2 over 1. Therefore, what I can say is the tangent of theta is -1/2. And now, so-called TOA, based upon my trig definitions, I'm going to go, just like I did a minute ago, I'm going to create a right triangle based upon knowing this trig function. Now, just so you know, even though this tangent's negative, when I create my right triangle, I don't worry about having negative numbers, because the lengths of the sides of the triangles are always positive. So in other words, opposite is going to be 1, adjacent 2. Now I'm at the point now where I've done Pythagoras enough where if you work it out, that hypotenuse should be square root of 5. Now, I told you a little bit ago, one of the keys when working these kinds of problems is when you start figuring out the rest of your trig functions, it's 2 steps. The first step is you figure out the actual number, but then the second step is you got to figure out whether it's plus or minus. Now, this piece of information here is going to help us determine that. First of all, tangent of theta is negative 1/2. What do we know about the quadrants if the tangent's 1/2? Now here's something else we have to review real quick. Something that gets used a lot is, turns out when we're working with tangent, the tangent can always be seen as the sine over the cosine, a fraction, sine over cosine. This also helps us when we're figuring out whether these tangents are positive or negative. So for us, our problem, our tangent's negative. I'm trying to figure out what quadrant this angle might be in based upon the tangent being negative. So if I think about the 4 quadrants, which quadrant or quadrants is the tangent negative? Well, if the tangent is the sine over the cosine, the only way tangent can be negative is if the sine and the cosine, if one's positive and one's negative. Either way. Sine and cosine cannot be the same, positive or negative, because if they're the same, then the tangent would be positive. They have to be opposite. One of these has to be positive, and one of these are negative. So which quadrants, of the 4 quadrants, which quadrants are such that the sine and cosine are opposites? As it turns out, that happens in quadrant 2 or 4. So now, based upon the tangent being negative, I've narrowed down that my angle is either in quadrant 2 or 4. But the question is, okay, but which one is it in? It can't be in both. And that's why they give us the second piece of information. They say the secant of theta is less than 0 or negative. Now, what does secant get paired with? Secant gets paired with cosine. And I just said a few minutes ago that the secant and cosine will always have the same positive or negative. So that means if the secant is negative, what do I know about the cosine? The cosine is also going to be a negative number. Now, based upon that, let's think about the cosine being negative. Of the 4 quadrants, for which quadrants is the cosine going to be negative? And if you need to think about it, cosine tracks x. So if you think about your quadrants here, which quadrants is x negative, which means cosine negative? Turns out quadrants 2 or 3 is where the cosine is negative. So when you compare these 2 facts, so I could say quadrant 2 and 3. So now I say, here's the conditions for the tangent. Here's the conditions for the cosine secant. Which ones are the same? They both have quadrant 2. So that tells me this angle is in quadrant 2. So that means now I'm going to go start figuring out my trig functions. And I'm going to figure out the number. But after I determine the number, then I can go look at the quadrant the angle is in and determine whether it's plus or minus. So let's just do that. Let's just start with sine theta, so katoa, so opposite over hypotenuse. So that's the first step, the number, and then I have to decide whether it's plus or minus. Quadrant 2, what is the sign in quadrant 2? The sign tracks y. What is y in quadrant 2? Well, it's positive. So therefore the sine of theta is just positive 1 over square root of 5. How about the cosine of theta? So ca adjacent over hypotenuse. So there's the number. How about the plus or minus? In quadrant 2, what is the cosine? Cosine is just like x. What is x in quadrant 2? It's actually negative. So that means the cosine of theta is negative 2 square root of 5. Now tangent, we already figured out from up here, once we took reciprocal quadrant, so tangent is negative 1/2. Now let's go get the other three trig functions, right? Sine is grouped with cosecant. So you take the reciprocal, and the plus or minus is the same. So if the sine is positive, the cosecant is positive. Cosine is grouped with secant. Flip the parenthesis, and then since cosine is negative, secant is also going to be negative. And then, of course, we were given this. If you flip the tangent, you get cotangent. And there you go. All right. Now there's one more kind of problem they give you where you have to use sort of right triangle, trig function kind of stuff. And that's one where they actually give you a point on your x and y graph. So for example, the instructions say find the 6 trig functions if the point, so here's a point, if the point 12, negative 5 is on the terminal side of the angle theta. So basically, we're going to graph this point, and we're going to draw a line from the origin of that point, and then we're going to look at the angle that gets created. So 12, negative 5. 2, 4, 6, 8, 10, 12. So 12, negative 5 is maybe right about here. So what I'm going to do is from the origin, go to that point, and in a sense, they're asking me to figure out the 6 trig functions for that angle. Now we explained in class, I don't know how to find the trig function for that angle. Instead, what I'm going to do is I'm going to find the trig functions for that angle, and it actually is going to be the same. The trig functions for this angle and the trig functions for this angle are the same, amazingly enough. So what I've got here, I've got a right triangle. Turns out this length here is 5. This length here is 12. Now I can use Pythagoras to find the length of this one, and if you do it, it's sort of nice. It turns out it's a nice number, 13. So what have I done? They gave me a point. I plotted the point. I took a line from the origin to the point. Based upon that, I created a right triangle. And now, as it turns out, I can start figuring out my trig functions. And it's very obvious, right, that this angle is in quadrant 4. So that's going to help me determine whether things are positive or negative. So the sine is, so here's my angle opposite 5. So opposite over hypotenuse. In quadrant 4, what's the sine? The sine is like y, it's negative. So ca adjacent over hypotenuse. What about cosine in quadrant 4? It's actually positive, so here's the cosine. Tangent, so catoa, opposite over adjacent. So in quadrant 4, what's the tangent? Well, the tangent's sine over the cosine. And since the sine is negative, cosine's positive. Turns out the tangent is going to be negative. Now we can find the other 6 trig functions pretty easily. If I just flip this, cosecant, keep the same sign, keep the same positive and negative. Oops. Secant is grouped with cosine, so you flip the cosine. It's positive, positive. Cotangent is reciprocal of the tangent, and the sine stays the same, and you get negative 12 over 5. Now I want to make sure I didn't mess up. I did. I don't want to mess up. Yep. This checks out. I'm delaying because, let me be very careful. I don't want to mislead you. And then cosine 5 over 13. Aha! Maybe you saw this. I did mess up. Good thing I checked. You probably were screaming at me as I was doing this. You got to be careful with these and really talk it over and talk it out. Because if not, you mess up. So we make sure. Cosine 12 over 13. Secant negative, or 13 over 12. Tangent negative 5/12. Yep, those are correct. All right, well, I'm glad I checked. So just be careful. It's not that hard, but just got to be careful. All right, so we're going to stop now, and we'll start, I think, working on trig graphs in the next video.